Hey, this is James. I'm going to show you how I mounted the 36-in-1 crank trigger wheel to my Porsche 944 2.5 liter motor, and how I designed and created or 3D printed the hala-fax sensor mount here. And I lost the footage, of course, because it's been a while since I've done it. And I'll do a screen share here later in the video, show you some design iterations I went to. But essentially, this is the mount that I came up with. Here we go. Here's the 36, the 6-inch wheel with the missing tooth, hala-fax sensor from DIY Auto Tune. It's either going to go in the front there on the pulley or right between the timing cog and the pulley. So if I put it in the back, I gotta clearance it all out there. If I put it on the front, like I probably will to begin with, I can let it ride out front and figure out. I don't know how long I'm keeping the system on here, because I do have an i5 going in, but I got title issues. I need to get the car running without much money, as I've been talking about. And this is how we're going to do it. All right, here we go. So if I want it to go here, I got to clearance this part right here to get it to go flush, to fit around this bolt here. All right, so and I'm going to cut it to fit around there so that it's absolutely in the center. I wonder if I can do that. This will be interesting. Let's see how much play there is. All right, so we got a little bit of play here. What I'm going to do to begin with is I'm going to go get some I guess probably 8mm nuts, and we'll get the caliper out and do some measurements, get it tightened down, and then we will use the outline here to draw for this lip here. So here we go. So it centers out pretty good wise. I'm just going to check it now with my caliper, do some measurements out from that inner race that we're going to go around that's in there to the outside teeth there, or the inside teeth. We'll just do it right next to the bolts so we can just make sure it's square. I measured everything in the same spot, and I came up at 50.5 millimeters for everything. When I went around, I had to bump it with my hand a couple times, and then it just came right in. So now I'm going to be careful with it and use my black marker to trace the inside, and then I think I'll flip it over and trace the other side too, and then I'm going to figure out the best way to cut this sucker. All right, I used the Sharpie, got right up in there so that there was no shiny left. And you know, probably it's useless. I'm probably not going to cut from this side. I'm going to cut from this side. I want to find something that's 70 millimeters. I know it says 70.09, but it's really 70 millimeters. And so what I did is I used black Sharpie and I drew right on the, you can see here on the left side, right on the orifice. So I want to cut on the outside of the line here, but I want to get something cut out that's 70 already to trace around it, to get a good tracing before I start with the jigsaw and cut it. All right, my ball joint breaker kit has a 70.15 inside diameter, so this might work. I'm going to give it a shot. If not, I'm going to be 3D printing a piece instead. But we'll give this a shot and see. Okay, the jigsaw with a medium metal blade is working out pretty good. I'm just clamping it on a staircase up to my storage loft above my garage. And I think that's a ticket. I'm pretty happy with that. It's not perfect. You can see right there I got off. You know, my plan was to go right on the line, but I decided to go right on the outside of the line. That way I have some adjustability as I'm tightening it up on the outside. Okay, here's how it turned out. You can see where I didn't cut, so I got off a little bit. I think it's all right. We're just, hopefully there's enough play. If not, I'll die grind out whatever. I already hit it with the drill mill die grinder. So I'll put this back together and we'll measure out 50.5 millimeters. And hey, look what I got. Reminds me of shop class, metal shop class from a junior high when we used to make throwing stars or karate stars back in 79 and 80, man. Should sharpen that up. This thing would be wicked. All right, turned out pretty good. Right on 50.5, 50.49. So I call that pretty good, I think. The engine shakes like shit. Well, no, it's not so good, but it shouldn't. I've seen other guys cut this out, and this is essentially what it looks like when they cut it out. Time to mount it back up to check out all the clearance issues. All right, here's what it looks like. I did put one, I had to space it a little with a just a washer. You can see we're right up on that, but there's enough clearance, depending on the, I guess, how good the thrust is. The thrust bearings are on this thing. If I had to do over again, I'd get the smaller one. Definitely. And I can also place it on the outside of here, which on this guy here will fit right up. And I can make this work by clearancing it here and here, and having it hang out on the bottom like this if I want, or we work on a clearance right through there. Actually, might just do it that way. And then I'm going to come up with the hala-fax. I'm going to 3D do some measurements here and 3D print. And I'm pretty sure we're going to use this mounting here. I don't have power steering, so I don't have to worry about it. This is the alternator adjustment bracket, the tension bracket. I have it unhooked right now, but essentially I can use these two to tie in and get right up in there. Look how good that is. I mean, that's going to be an easy print to do. And again, we can just clearance the plastics, but I can even make it a little bit adjustable there. So I think I'm going to go just like that and do some measurements here. I'm just going to start with doing it by eye. I'm going to measure this. We'll 3D print out basically an L bracket that will go right like that, and we can just use some washers to just tweak ourselves right up tight on the wheel. So I got to do some more reading and make sure I can do that in the right position, and how I have to position everything to make sure I get the right count, and that everything can, micro squirt can handle it. All right, here we're going to pick up on where I did the design to make this all happen. Right here on the edge of this picture, this is the mount for the air conditioner compressor, which I don't have on my car, so that's how come I can use this. Most people use the bar across here and go off at the 180-degree direction. Basically, I'll be 80 degrees before top dead center. And that's the value that I'll put into Tuner Studio to program the micro squirt with. So essentially what we're doing is creating the bracket here. You can see the two holes, and it fits in like this, and then the tab goes into here, and the hala-fax comes out of here. And I'll show you the couple of design phases I went through. It was a lot simpler than this one before, but then I would get it. I would get loss and vibration, signal loss, because I think of vibration and also expansion of the material I was using. This one is printed in PEG G carbon fiber, which is shown to be pretty good. I also have nylon carbon fiber and ABS that I can print in that have also shown to be good too. But this version that I'm holding here is good old PEG G carbon fiber. I noticed on other videos the mouse was trailing off of the 180 position and the 80 position of the crank wheel there, so please ignore that. All right, so here we're in Fusion 360. You can use anything that you want. I happen to start on this, and so kind of that is my preference. Basically, I drew two planes of what I wanted to extrude. These are the mounting holes to the AC, and this is the hole. This has given me an extension where I could adjust the hala-fax sensor. I since had dialed it in. You can see I'm on version 4 of this initial one here, and then I moved all the way up to version 13. So basically, it's just a couple simple extrudes to make it happen, and then export it as a STL and print her out and fit it on. And so I definitely moved my way in there a couple times. See all the different versions that I went through of playing around with it. Basically printing many times to make it fit the way that I wanted to, and then I had the car firing probably on some of these versions down here easily, but I'd lose crank signal because of material expansions and vibration, I think, and so we ended up here with version 13. So here's the final end of it, and it's pretty simple. Still, basically, it's got the two planes, the horizontal and the vertical, and basically the horizontal is what basically extrudes upwards, and the vertical is done with an extrude cut that ends up with this shape here. And let's just do a 3D rotate here to see what she looks like, and that's pretty much it. That's just mounted off the AC there. You can see I had to change the angles a little bit. They started in line, but then to dial it in, and that put me right around, I think 75 or 80 degrees before top dead center, and that's it. So I do have the car running on micro squirt, and next couple of videos will show you how I got there on other parts. Until next time, this is James.